This is logarithmic graphing. So first we're going to look at exponential graphing. If I look at an exponential function, y equals 10 to the x, the initial value is 0, and the growth factor is 10. So if I plugged in 0, solve to get y, and I plug in 1 and solve to get y, those are the two easiest points to plug in. So I'm going to go ahead and do that. 10 to the 0 is 1. Anything to the 0 power is 1. And 10 to the first is 10. So I can plot these 2 points. I get this exponential function, horizontal asymptote of y equals 0. The logarithmic function, log base 10 of x, is the inverse of this function, 10 to the x. So the exponential and the logarithmic are inverses of each other. So when I think of inverses, I think of switching the x and the y values of the ordered pair, and then plot those 2 points. So I'm going to plot 1, 0 and 10, 1. When I plot those 2 points, I get this graph. If you notice, these two graphs are inverses of each other. That means if I graphed them on the same plane, they would be symmetric about the y equals x line. So they are symmetric about that line. Let's look at another set of exponential and logarithmic. So the next function we're going to look at is the exponential function e to the x. The initial value is still 1. Anything to the 0 power is 1. Then when I plug in the number 1, e to the 1 is just e. So I can plot those 2 points and we get this exponential graph. Now log base e is a special log. We call that the natural log. We write it like this, ln of x. Generally, we don't write the e there. It's assumed that that's base e. Natural log is base e. The same thing for log base 10. We don't usually write 10. For example, in your calculator, log is assumed to be base 10. So when I don't have any base, and I'm talking about log, the base is 10. When I don't have any base written, and it's natural log, the base is e. So again, these two functions are inverses of each other. E to the x has a horizontal asymptote at y equals 0. Natural log of x has a vertical asymptote at x equals 0. We're now going to talk about evaluating logs. How do I evaluate a log? Well, we can rewrite it as an exponential function, and then use our skills to get the same base and solve for x. But first, we need to take this log and be able to read it. I would read this as log base b of y equals x. That's log base b of y equals x. So this number right here, whatever number is here, is the base. Remember, if there's no number there and we're talking about log, it's assumed the base is 10. If I want to rewrite this log in exponential form, I start with the base, b. Then I raise it to this power, and it should equal this value. Let me show you how to do that. So here's example 1. We read this as log base 2 of 8 equals what value? Log base 2 of 8 equals what value? Well, let's rewrite this in exponential form. We rewrite this, the base is 2, so I say 2 to what power equals 8? So I rewrote this in exponential form. Then I said I can rewrite 8 as a base of 2, 2 to the third. Drop the bases, x equals 3. So this value right here is 3. Log base 2 of 8 is equal to 3. Let's try a couple problems. Press pause. Try and evaluate these 3 problems. Press pause now. Okay, so hopefully you got those problems correct. Let's move on and find some rules that we can make for general problems. So let's take a look at these problems. We realized in the problem above it that any base to the x equals 1. The power is going to have to be 0. So whenever 1 is here, it doesn't matter what the base is. Whenever you have 1 here, this is equal to 0. For the next problem, remember, it's assumed that we have a base 10 because there's no base there. So log base 10 of 10. If I think about rewriting this in exponential form, this says 10 to what power equals 10? Well, 10 to the first power equals 10. So this is going to be 1. In fact, in general, if this base is the same number as the number we're taking the log of, it's always going to be equal to 1. For example, if we had log base 2 of 2, that equals 1. Log base 3 of 3 equals 1. Anything when you have the same number in the base and the number we're taking the log of, it equals 1. For this one, we can say the base is 10. 10 to the what power gives me 10 to the y? Well, that's y. So we can say in general, when the base and this number are the same, and you have an exponent, you can cancel these out and we just are left with the exponent. It happened up here above. What was the exponent here? 1. We just don't write it. Well, if I think about the same base as the same number here, cancel it out, we get 1. Same base, same number here, cancel it out, we get y. This happens here as well. This says log base 10 of x. And our base, this is an exponential function. Our base here is 10. So these again cancel out and we just get x as our answer. So try these problems. Now we're talking about the natural log. See if you can figure out the answers to these 4 problems. Press pause now and then press play to check your answers. Okay, check your answers. So remember, when I have the natural log and there's no base written, we're assuming the base is e. So e to the 0 power gives me 1. Any base of 1 is 0. This is always going to be 0 if this number's 1. For the next one, remember our base is e. E to the 1 equals e. When the base and this number are the same, we can cancel it out and write 1. Same thing here. The exponent is y, and the base and this number are the same. Natural log base e of e to the y. Cancel out, and we're left with y. Again here, e to the natural log base e of x. These cancel out, and we're left with x.